Welcome. Welcome again. Let's solve Leetcode 1368, minimum cost to make at least one valid path in a grid. Okay, so let's make this bigger so we can read it. All right, cool. All right, so we're given an m by n grid. Each cell of the grid has a sign pointing to the next cell you should visit if you are currently in this cell. The sign of the grid I can be so either 1, 2, 3, or 4. And 1 means go to the right, 2 means left, um, 3 means go down, and 4 means go up. Go up. You will initially start at the upper left cell 0, 0. Some signs point to outside of the grid, and the goal is the bottom right corner, and we start from the top upper left corner. The valid path does not have to be the shortest. They give us this twist here where it says you can modify the sign on a cell with a cost of equals 1. You can modify the sign on a cell one time only. And they would like us to return the minimum cost to make the grid have at least one valid path. Okay. Now, so they give us this, for this example, they give us this diagram. However, though, what we're really given is this here, these numerical values. And the 1s mean go to the right, 2 means go to the left. So given this input, the minimum cost to traverse from the upper left to the lower right corners is 3. So let's see why that is. So suppose we start here at the yellow location, and we can freely move with the flow of the arrow without incurring any cost. So if we move to the right, to the right, to the right, we can get to this upper right corner with no cost. Now we need to remember our ultimate goal is to reach the bottom right corner. So if we change the direction of this cell, so this would cost us once. Change the direction of this cell, that would cost us 2. Change the direction of this arrow, this would cost us 3. And then we would arrive at our destination, our goal. Hence the expected return value is 3. Okay, let's check out example 2. So if we follow the flow of the arrows, so go to the right, then we go down, go to the left, go down, go to the right. Notice how we don't necessarily have to change the direction or the flow of an arrow, because we can reach our destination at 0 cost. It may not be the shortest path, but it is the lowest cost. And okay, and let's go over this last example. So we're told we can go to the right for free, so we go to the right. Well, our goal is the bottom right, so let's maybe adjust this arrow. So that would give us a cost of 1. And so at that point, we've arrived at our goal destination. So the expected result is 1. Okay, I think that isn't too bad. So what we're going to do is I recommend we use a modified version of breadth first search. Previously, when I solved this problem, I used Dijkstra's, and even though it worked, it was just a little bit slower, but it turns out that if we modify breadth first search to accommodate this new cost approach, or like meaning like if we go the arrows, it's 0, but if we change them, it's 1. If we modify our breadth first search to account for those small modifications, we can get a pretty decent performance. Okay, so let's get started. Maybe we can move this out of the way. All right, let's make this bigger. Okay, I think we can almost code it, and maybe I'll explain stuff as we move along. So remember, I think it's pretty natural to want to know the size of the grid. So let's do that. So let's get, so row and column equals the length of G and the length of the first element of the row, just to get at the columns. Okay, so we know that. And okay, and typically for breadth first search, we'll be using a double-ended queue. So I guess we can start with that here. So maybe we'll say queue equals double-ended queue, and let's put our first. We'll place on the queue our current location, or the locations we want to explore, and this will be what row column. So row. Well, I think it's obvious, but this is going to be, this is the row, this is the column. So we're starting at 0, 0. Okay, maybe just put this initial location, initial cell. Okay. Now, remember we can go, we're allowed to traverse this graph in any direction, meaning like we can go sideways, down, to the right, back up. So we can traverse we're not necessarily confined to down or to the right. We can traverse the grid in any sequence of directions. Okay, so let's set up a directions array here, or list. So I'm gonna call this dirs. As a note, well, I'll leave it like that for now. I'll explain it in a moment. So let's do 0, 1, and I'm gonna place these in a particular order. 0, -1, and I'll also explain that in a moment. 1, 0, and what is this? -1, 0. So they tell us, what do they tell us here? They tell us that 1 means go to the right. So that's kind of what we have here. This means add 1 to the column, which goes to the right. Go to the left means subtract 1 from the column. So that's why I place this particular value row column here, and go to the lower cell. So this means we would add 1 to the row and do not affect the column. And here means go up, so we subtract 1 from the row. Okay, so in essence, those are like our delta row, delta column, for those of you who are familiar with calculus or something like that. Okay, what else do we need? Let's store our, like, the best distances we have so far. So what we'll do is we'll say, okay, we'll use a two-dimensional grid to store the minimum cost to get to that point. So we'll say d equals, okay, we'll say maybe math.infinity times the number of columns for, we don't need this variable, and range row. Okay, so this will store, initially we'll have a grid the same size of our grid here, and they'll have the minimum distance to travel to that particular cell. And again, this is basically a mirror of the grid. So it makes sense that we initialize our initial row and column, and it incurs a 0 cost to get there. Okay. I think that's all we need in order to initiate our traversal. All right, let's do that. Okay, so let's make this a little bit smaller, and I think we can move this for now. So what we'll do is we'll say, okay, so while we have elements in our queue, and let's remove the first element in our queue, our double-ended queue. Sorry. Oh yes, I remember now. I mentioned earlier that I was going to explain this DIRs here. So in Python, there's a. I guess let me do something here. Print. Okay. So this will explain to you why I call this DIRs instead of dir. Okay. So let's continue where we left off. So so we're using a double-ended queue, and what we'll do is our idea is this. So remember here, let's go to example 2. So what we can do is we should try just going with the flow, meaning like with the direction of the arrows, because that's a zero cost. And it is possible that we can reach our destination as we did here without incurring any cost. And notice how the cost is 0 here. So my point to you is, let me write this at the top. Actually, maybe just here. I think it's fine. We will prioritize zero cost movements first. Okay, so in a moment I'll show you how that reflects in code, but I've written it here because that's important. Okay, so again, we will prioritize the zero cost movements first. Okay, and then afterwards, if that doesn't work, then we'll resort to changing the direction of an arrow. Okay, so let's continue on where we left. Continue where we left off. So let's remove our current location. So we'll say row column equals q.pop left. So remember, we're using a double-ended queue first. So we'll always, and remember, this is a modified version of breadth first search. So we'll always want to pop from the left first, because those will be our nearest neighbors, and then and the farthest neighbors will go on the back end of the double-ended queue. Okay, so we'll pop our first element from double-ended queue or deck, and then we'll say, okay, we'll check if we've reached our destination. So we'll say if this equals, now where is our destination? So we know our row and column here, so we'll say row -1, column -1. If we have reached this point, then we can just return the value we have stored there. So we can do this here. This will work. And remember, this stores minimum distance to that cell. Okay. So next, moving on. Otherwise, if we haven't reached our destination, we should try exploring our neighbors. So at this point, remember, we start here at yellow, so our neighbors would be this to the right here and lower cells. So let's do that. Okay, so let's loop through our directions. So let's say, okay, for dr, dc, in dirs. Now, so we have something to the tweak or the adjustment we need to make is here. So remember, we have these rows here, or sorry, these arrows, and remember, if we go the same direction as the arrow, there's 0 cost. But if we change the direction of the arrow, there's a cost of 1. So let's incorporate that into our exploration here. So what I'm going to do here is I'm going to say enumerate dirs. And so typically enumerate starts at the value, the index 0. So what I mean by that is this. I'm going to say this here. So I'm gonna put I here, and I'm gonna put parentheses here. So let me just do something here. Actually, let me take this out. No, I think this is okay. And I'm gonna print I'm just gonna print, that's fine. And we'll just print DRDC, it doesn't really matter. And then I'll just, for now, just return 0 so we don't get an error. I wanna show you something here. Well, and this too. So let's see, I think that's okay. Okay. Okay, so let's see. Okay, good. So in Python, we have to remember that dir is a special function provided by Python. So we should not override it. So so don't do that. So that's why I call this dirs. Okay. And typically it's used to inspect an object for any methods or instance variables it has available. So feel free to explore that. And where are we at? Oh yes, here we are. So notice we have 0, 1, 2, 3 here. However, and remember 0, sorry, let me take that back. So notice how this 0, 1, if we were to add this to our current cell, this would mean go to the right. However, though, remember though that 1 means go to the right. So what we can do here is a little bit of a trick here, or not a trick, but understanding of Python's enumerate function. We can actually add a, you can tell enumerate where to start. So I'm going to tell it to start at 1 instead of the default of 0. So let's run that again. And now notice how, so 1 means go to the right, which is also what this means. And 2 means, for them, it means to go to the south to the left. And that's what happens here. When we subtract 1 from the column value, that would mean to, or that would shift us to the left. And the same thing for this 3 and 4. So I wanted to make our life easier. So that's why I've decided to use this approach here. So instead of I here, I'm actually going to call this direction. Okay, so I hope that makes sense. All right, so then, well, what do we do here? So let's kind of perform some manipulation and see where we would be. So let's set up the new row and the new column. So the new row would be the current row plus our delta row, and the new column would be our current column plus the delta column, the change in the column. Okay. What else? And now, well, it is possible that these values are outside of the grid. So let's perform a check first. So we'll say if the row is within the proper bounds and the column is within the proper bounds, then we can continue. Or, I mean, we don't need to, we can perform some operations. Okay, so that means if we're within this block here, that means this new row and column are good to go, meaning they're within the bounds of the grid. Okay, so let's check a cost, check the cost we'll be incurring. So remember, if we're here and we want to know if we're at this point here, if we're going to the left, the cost would be 0, but any other direction, that would be 1. So what we'll do is we'll check the cost. So we'll say cost equals if, so 0, if the direction is the same as what? So if this direction is the same as the direction at the cell, so we can say if that is equal to the direction at that cell. Sorry, that's okay. So direction of, yes, that's right. So we're here, and we can go left, up, right, or down. So we want to see if so the direction of the current cell. So the direction of the current cell. This is the direction of the current cell. If that is in agreement with the direction that we're currently interested in or focusing on. So I hope that makes sense. So imagine we're here at this yellow arrow, and so we want to check if our surrounding, remember this is for our surrounding neighbors. If the surrounding neighbor is in that direction, then the cost is 0. Otherwise, the cost is 1. Okay, so I hope that makes sense. Okay, and then moving on. And then we check now if the cost to this current cell plus this cost to travel to the neighbor, let's write that down. So if the cost of the current cell was this, so it's, what is it? So it's going to be d of RR. So that's the cost to get to this cell right here. This, remember, that's what this stores. Stores the minimum cost of that cell. So if the cost to get to that cell plus this cost to travel to the neighbor, if it's less than the cost to get to that neighbor, then we can continue on and add that to our double-ended queue for exploration. Well, let's first update it. So since this cost is better than this cost, let's update it. So we can say the new cost equals the cost to travel to the current cell plus the cost to travel to that neighbor. Okay, and now we have a little bit of the modification here. So what we're going to do is, suppose we have this here. Let's call this, maybe, I don't know, something like this here. So these are all the cells that we need to these are all the cells that we're about to explore. But what we should do is, so notice the way that we're working with this is that we pop from the left first. So in that case, if the cost is 0, we should place those cells in the front and the other cells that cost something in the back. So that's what I mean by this here. We want to prioritize, we will prioritize 0 cost movements first. Okay, so how do we do that in code? All right, so no problem. So it's almost exactly that. So if there is a cost, so it costs something, then we say, okay, q.append our row and column. But if there is no cost, then we say q.append left row column. So I hope that makes sense. So if there is no cost, we put it to the front. If there is a cost, we put it to the back. We put the new cell to the back. Okay, I think that's it. And then it's I think that's about it. We don't really need this anymore, because what's going to happen is we return here. We return here. Okay, let's check the tests or run the tests. Okay, looks good. Let's submit it. Maybe like this. Maybe make this smaller. Let's submit it. Okay, looks pretty good. Okay, if you found this video helpful or beneficial or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself. Cheers.